So this is going to be part 2 of domain and range. And in the last video, we talked about a couple of the parent functions and how to find the domain and the range. Well, the domain is going to be the set of all x values. It's the set of all inputs into a function. And the range is going to be the set of all y values, or outputs of a function. So when we try to guess the domain and range of a graph, we're really taking a look at the graph and seeing what x values does the graph take up and what y values does the graph take up. Those are the questions that we're going to be asking ourselves. So this function is the sine function. It is f of x equals sine of x. And this is one of the trigonometric functions. This is one of the trig functions. So we're given a specific domain for the function. The domain is going to be the set of all x values. So what we're going to be doing is we're going to be looking at the x values that the function takes up. Now for the x values, remember that we're looking at the x-axis. The x-axis is going to be this horizontal axis right here, running from 0 all the way to 2 pi. So the function is going to start at 0, and it takes up every single real number between 0 and 2 pi. So the domain is going to be x is greater than or equal to 0 and less than or equal to 2 pi. So that's the domain. That's the x values that the graph is going to take up. Another way to write this would be the closed interval from 0 to 2 pi. 0 to 2 pi. And this is going to be a closed interval. So both sides are going to get brackets. And what that's going to do is that's going to include 0 and 2 pi in our set, because those are the endpoints. Now let's look at the range. The range is going to be the set of all y values. So we're going to be asking ourselves, what y values does the graph take up? So looking at the y-axis, which is this vertical axis right here, we see that the graph starts at 0 and it goes all the way up to 1, and then it stops. And then it goes all the way back down to 0 again, right here, and then it'll go all the way down to -1, and then it'll stop, and then it'll go back up, and then it will stop at 0 right here. So the function is essentially going between 1 and -1. 1 and -1. So the lowest that the function ever goes is -1, but the highest that the function ever goes is +1. So the range is going to be from -1 to +1. Y is greater than or equal to -1 and less than or equal to +1. Another way we can write this is the closed interval from -1 to +1. And we're going to close that up. So that is the range, the set of all y values. So when you think domain, think of x values. And when you think of range, I want you to think of y values. So let's look at this next one. This is actually a V-shaped graph, and that lets you know that this is y equals the absolute value of x. You can write it this way, or you can write it as ABS of x. Two ways you can write that. So this is the absolute value graph. We're going to find the domain and the range. So the domain is going to be the set of all x values that the function takes up. So which x values does the function take up? Well, if we look at the x-axis, it appears that the function is going to go all the way to the left and all the way to the right. So this domain is going to be all real numbers. All real numbers. Another way you can write that is capital R. Okay, so now let's think about the range. The range is going to be all the y values. So what y values does the graph take up? Well, looking at the y-axis, it looks like the lowest that the function ever goes is 0, and the highest it goes is all the way to positive infinity. So the graph starts at 0, and it goes all the way to positive infinity. So one way we can write this is y is greater than or equal to 0. Because think about it, y can be equal to 0, like it is at this point, but it can also be greater than 0, like it is at this point. So y is greater than or equal to 0. We can write that as a set with a closed bracket at 0 and an open parentheses for positive infinity, because the range is going to start at 0 and go all the way to positive infinity. So that's the absolute value function, and its domain and range. Okay, so let's move on to our next function. This is the cube root function. The cube root function. And that's going to be the cube root of x. The domain is the set of all x values that the function takes up. And for this graph, it keeps on going to the right. So I'm going to put arrows onto the right side, and I'm going to put arrows onto the left side, because the graph is going to go all the way to the left. So that means the domain is all real numbers. All real numbers. Or capital R. The range is also going to be all real numbers, right? Because the graph is going to go all the way to the top, to positive infinity, and it's going to go all the way to the bottom, which is going to be negative infinity. So this is also going to be all real numbers. All real numbers, or R. Another way you can write this is from negative infinity to positive infinity. But since we're dealing with infinities and not real numbers, we have to use these open parentheses to end the intervals. So that is the cube root of x. Okay, this function is going to be our first exponential function. This is y equals 2 to the x power. So this function has a horizontal asymptote. A horizontal asymptote. The horizontal asymptote is actually the x-axis, or y equals 0. So this function is going to have a horizontal asymptote. What that means is the graph is going to get super close to 0 down here. It's going to get super close to 0, but it's never going to actually be 0. It'll get to numbers that are arbitrarily close to 0. So when we think about the range, that's going to come into play. Okay? But the first thing I want to do is I want to find the domain. The domain. The domain is going to be all the x values, and the function is going to keep on going to the right, and it's going to keep on going to the left until you get to negative infinity. So the domain is going to be all real numbers. All real numbers. But the range is not going to be that, right? Because we have that horizontal asymptote. So think to yourself, what are all the y values that this graph takes up? All the y values. So we start at 0 and we go all the way up to positive infinity. All the way up. But the function never really gets to be 0 down here because of that asymptote. So we're actually going to include an open parentheses where the 0 is, and an open parentheses, of course, where the positive infinity is. So this, another way you can write this is y is greater than 0. It can't be equal to 0 because of the asymptote, but y is going to be greater than 0. So all the positive real numbers are included within the range. And that is the exponential function y equals 2 to the x power. Okay, now this is the opposite of an exponential function. This is a logarithmic function. A logarithmic function. And this kind of function doesn't have horizontal asymptotes, but it does have vertical asymptotes. Can you see where the vertical asymptote would be? It would be the y-axis, right? Because the graph never crosses the y-axis. So we say the vertical asymptote for this function is going to be x equals 0, also known as the y-axis. Now that's going to affect the domain, because remember, the domain is the set of all x values. Well, which x values does the function take up? Everything that's bigger than 0, pretty much. We don't get any negative numbers within the domain over here. And we don't get 0 either. So we can write this as x is greater than 0. Or you can also write this as parentheses 0 to positive infinity. Parentheses. Now the range is going to be all real numbers. And I'll tell you why that's the case. All real numbers. So when we think about range, we think about y values. We think about which y values does the function take up. And the function goes all the way down, and it goes all the way up. So it's natural to think that the range would be all real numbers. So that's the logarithmic function. And the reason why the domain is cut up is because we have a vertical asymptote on the y-axis. All right, and the last function we're going to look at today. This is y equals 1 over x, also known as the reciprocal function. The reciprocal function. So this function, we want to look at the domain, which is the set of all x values, and we want to look at the range, which is the set of all y values. So we ask ourselves, what x values does the graph take up? Well, the function is going to go all the way to the right, going this way, and it's going to go all the way to the left, going this way. But what happens in the middle is where the controversy is. See, we have a vertical asymptote right here, so the function can never be 0. What that means is we have a break within the graph. So the domain is going to be all real numbers except 0. All real numbers except x equals 0. What about the range? That's going to be the same thing. Because think about it. What y values does the function take up? It goes all the way to the top. It goes all the way to the bottom. But we have this horizontal asymptote on the x-axis. So 0 is not included in the range. So this is going to be all real numbers except y equals 0. All real numbers except y equals 0. So that is the domain and range of y equals 1 over x.